Right, so we're on number 5 of this exercise that you've been working through, and it talks about now to determine the equation of the line BD, which is the median from B to the midpoint of the opposite side. Okay, so there's a little definition for you as to what a median is. The median here is the line that goes from B to the midpoint of the opposite side, which is D. So you know B's coordinate, -2, -2. And you know D's coordinate, which was 3 and 0. So you're simply finding the equation of a straight line. Okay, so here's number 5 solution. Firstly, you need to work out the gradient, which works out to be 2 over 5, change in y over change in x. And then we've now substituted in the value or the coordinate of D, which was 3 and 0. So remember the formula, y minus y1 equals m brackets x minus x1. So y minus 0, because D's y coordinate was 0, equals 2 over 5, our gradient, x minus 3, because the x coordinate of D was 3. All you need to do now is multiply the 2 over 5 into the bracket, and you have got your equation of the median B to D, okay, which is 2 over 5x minus 6 over 5. Maybe let me just zoom in here a little bit. Okay, at this point, you have to now go onto the textbook and work out some textbook answers. I hope you did that, but I'm simply going to carry on with working through this exercise. Number 6, the equation of the line perpendicular to AB through C, which is now going to be called the altitude from C to AB. Okay, let's have a closer look here. The equation of the line perpendicular to AB. Okay, so there is AB over there. We want the equation of the line that's perpendicular to this line, right? So it'll be coming out from that line, and it's going to go through C. So it's going to go something like that, if you can see my mouse, my cursor. Okay, so that is called the altitude from C to AB. Okay, so first of all, if it's a straight line, we need the m and the c of the y equals mx plus c. If we know the gradient of AB, which I think we worked out in number 3, hey, we know the gradient of AB, it was the gradient of AB 5 over 6. So if the gradient of AB is 5 over 6, what would the gradient of this line be in order for it to be perpendicular? 5 over 6 would become negative 6 over 5, right? Let's find the answer where I am here. There we go. The gradient of AB is 5 over 6. So the gradient of the it just says the perpendicular bisector, or the line that's perpendicular to it, would be negative 6 over 5. Okay, upside down, flip it, and there's now a negative. Remember, they must multiply together to give you negative 6 over 5. C is the coordinate that the line will be going through. So we can go substitute C into our formula like so, and we're going to get the equation for number 6 as that. Y is equal to negative 6 over 5x minus 3 over 5. Okay, great. We then go to number 7, which says determine the equation of the line parallel to AC and going through B. So AC is over there, and now we need the line that's parallel to AC that's going to be going through B. So just by looking at my mouse here, I'd say that line would be what? Going down like so, parallel to AC. So AC's gradient, first of all, from number 3, gradient of AC was 3. So parallel lines have the same gradients. That means that the gradient of this line that we're working out must also have a gradient of 3. That's what that yellow line says. It's going to pass through B, which is negative 2, negative 2. So we can now substitute negative 2, negative 2 into our new formula, like so, and we're going to get y plus 2, because minus minus 2, equals 3, the end value, x plus 2, because minus minus 2, and we're going to get an end answer for this line, y is equal to 3x plus 4. Right. We then had number 8. Let's see if I can do 8 quickly. It says the inclination. Okay, I'm going to leave inclination for the next video, where we will unpack hopefully the next 4 or 5 questions.